This is a video presentation of Chapter 2, Section 8, Solving Two-Step Equations. This presentation is limited to fractions. If you're looking for the presentations on decimals or integers, please search my YouTube channel for those videos. What you see on the screen right now are the four examples I'm about to work through with you. Now, of course, the problem with fractions, especially when we're adding and subtracting, is we're going to have to spend time getting a common denominator. And since all these are two steps, at some point they're going to involve that process, so we're going to have to get common denominators really before we can do anything here. There is a shortcut involved here, much like there was with the decimal presentation. It's obviously a different shortcut, but will help us get rid of the fractions, but again, only after we get a common denominator. So let's go ahead and take a look at the first question here. 3/2 x plus 1/5 equals 3/4. So we'll start off doing that common denominator I've talked about. Remember, to find the common denominator, you're finding the least common multiple of the denominators, the least common multiple of the bottom numbers. So in this case, we'd be talking about 2, 5, and 4. Well, if I list multiples, which is exactly what I would do, the 2 list would go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The 5 list would go 5, 10, 15, 20. And the 4 list would go 4, 8, 12, 16, 20. So, common denominator here is 20, which means all these now need to have denominators of 20 to make this work. Now remember, whatever multiplier we would have had to engage to make 20 happen is the same multiplier then will apply to the numerator. So for instance, in this first fraction, to change 2 into 20, we'd be multiplying by 10. So I'm going to multiply this by 10 as well, and that's going to give me 30. To change 5 into 20, we'd be multiplying by 4. So I multiply the top by 4 as well, and that's 4. To change 4 into 20, we'd be multiplying by 5. So I'm going to multiply the top by 5 as well, and that's 15. So at this point now, we can go ahead and go through this problem and solve it out using the rules that we've already known for solving equations. Again, that would be that we can keep our variables on the left, as in the left side of the equal sign. Our lonesome numbers, or really any numbers, are going to end up on the right side of the equal sign. We can flip the sides at any one point if we need to, and opposite side to the opposite. When I want to move something to the opposite side of the equal sign, I do the opposite to it, the opposite of whatever it's presented as. So, looking at this, we know that variable x being on the left is a good thing, and we know that 15/20 being a number on the right is a good thing. But 30/20 and 4/20 are both bad things for us, at least as they are right now. So we're going to have to move both of those things. So let's start with 4/20. 4/20 has an addition sign in front of it, so that's what I'm going to move first. Again, the thing with the variable goes last, so this has to go first. So I'm going to subtract 4/20 from both sides. And when I do that, that's going to give me 30/20 x. Again, I haven't touched that yet. I haven't done anything with it, so it's just coming straight down. These two wash each other out, and it will leave me 11/20. Okay, so now this is a one-step equation, and it's multiplying. So obviously we'd have to solve it by dividing. But remember, we're talking about a fraction. As you've seen in other solving equation videos and demonstrations by me, we've never divided by a fraction. We just don't do that. Even when we just were working with fractions, forget the equation part, we didn't do that. We solved the division problem by multiplying by the reciprocal. So that's exactly what I need to do to finish this question here. I'm going to multiply by the reciprocal, which is 20 over 30. Now I think you can see why that works on the left side there, is because if we look at canceling on the diagonal, 20s are going to wash each other out, and the 30s will do the same, and just leaves me x, which is of course what I want, because that's what I'm solving for. Remember, that's the reason we keep the variable on the left by itself. On the other side, we do have a little bit of luck here, in that the 20s will do the same thing there as well, and will just leave me 11 over 30, which needs no reduction. So x after we've done all that work equals 11/30. Now I know you're eagerly awaiting the shortcut, but we'll see the shortcut more down in the 2 questions beneath. This second question, top right there, is a little bit different. Notice that this one is kind of like some of the problems you saw in the decimal presentation, in that you've actually got a fraction on both sides here. So really what you want to do here to solve is probably cross multiply. We've got 4 plus m over 3 equals 5/6. That's a proportion, really. And that's what we would do if it was just a regular proportion. We would cross multiply. And that's exactly what we're going to do. So I'm going to take the 4 plus m and multiply it by 6, and then also multiply together the 5 and the 3. Now, what is perhaps tricky for some people here is that multiplying by 6 there actually leads to a distributive property question. I'm going to go ahead and take that 6 through to both parts there. 6 through to the 4 is 24, and 6 through to m is 6m. And of course, we can simplify this. We don't really have to think about that. That's going to be 15. And we end up with 24 plus 6m equals 15. And now this looks more like a question from the integer presentation, because that's all it is. There's actually no fractions in this question, which is actually a good thing for us at this point because no common denominator involved. Okay, so we'll say to ourselves, keep that variable m on the left and keep that 15, that number, off on the right. So we see that the 2 things that are going to have to move here are going to be 24 and 6. Remember, the thing that's connected to the variable goes last, so 6 is going to go last, which means as a consequence, 24 has to move over first. 24, as presented, is a positive. The opposite of a positive is a negative. Negative looks an awful lot like subtraction, so that's why I'm going to subtract 24 from both sides. As you can see, these two will wash each other out because 24 minus 24 would go to 0. And so now I have 6m equals negative 9. Okay, so this is at this point now a multiplication problem, a one-step multiplication problem at that. So we'll finish by dividing. I'm going to divide both sides by 6. And even though the fraction disappeared throughout the problem, the fraction returns at the end here because we have negative 9/6, which reduces to negative 3/2. Now, some of you are probably wishing you could see that problem the other way. So let me quickly just go and show you how this problem worked if you went about the other way of solving here. It doesn't change the answer or anything like that. It's just a different way to solve the question. So, back in the beginning, what I said you could do is you could just get rid of the 3 that's in the denominator here by multiplying both sides by 3. Again, as we talked about in an earlier presentation here, pretend for just a minute that this top part just said x instead. Well, if that just said x, you know exactly what to do. We would be undoing dividing by 3 by multiplying by 3. Well, that's the exact same thing we're doing here, except it doesn't say x, it says 4 plus m. So I'm multiplying both sides by 3, and if you need to think of it as 3 over 1, you can. But what happens here is this simplifies to 4 plus m equals 15/6, and then you would subtract the 4 off both sides, and you would end up with an answer equivalent to negative 3/2 there. Either way you go, you end up with the same answer. It just depends really, in this particular question, if you really wanted to work with the fractions throughout or not. Okay, let's go ahead and take a look at the questions now at the bottom there. We'll start with the one on the left, which says 3/7 minus 1/4 y equals a half. So we'll start off, we'll have to do common denominators again as we did in the problem directly above it originally. Common denominator here is going to be 28. I would find that through listing the multiples. the 2 list, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. The 4 list, 4, 8, 12, 16, 20, 24, 28. 7 list, 7, 14, 21, 28. So 28 is our common denominator here. So I'm going to make all the denominators into 28. And remember, then we're going to say whatever multiplier I would have had used to make the bottom into 28, I'm then going to apply to the numerator as well. So to change 7 into 28, I'd be multiplying by 4. So I multiply the top by 4 as well, and that's 12. To change 4 into 28, we'd multiply by 7. Multiply the top by 7 as well. 1 times 7 is 7. To change 2 into 28, we'd be multiplying by 14. So I multiply the top by 14 as well, and that's 14/28. Now, here comes the shortcut. This is the first time we've seen this in the presentation. What you want to do is, once you have a common denominator, simply multiply the whole line by that denominator. What happens when you do that is it cancels this multiplier out with all the denominators, and it will totally eradicate your fractions. Notice it's changing into 12 minus 7y equals 14. The fractions are gone. That's exactly what some of you probably wanted, because writing all those fractions and over again turns out to be a lot of work. Now this looks kind of like an integer question. So we'll use the same rules we've been using here in this presentation, which are the same rules as integers, except I don't have to worry about the fractions anymore. It's possible the fraction could come back in the end result, but that's okay. So we say to ourselves, keep that variable y on the left, keep my number 14 on the right. So we've got to move both the 12 and the 7. Remember, the thing that's directly connected to the variable goes last, so 7 is going to be the last thing I move, which means 12 has to be the first thing I move. So, as far as moving 12, I'm going to subtract 12 from both sides. And that's going to leave me negative 7y equals 2 in this case. And now this is a basic one-step multiplication problem. Undo the multiplication by dividing, so I'm dividing out negative 7 all the way across. And as I said, that fraction could come back in the end, and indeed, it has come back in the end, but I don't have to do any work for it at this point. It's just my answer. Y is going to equal negative 2/7. Some people might be wondering, well, why did you move the negative to the top? Well, remember, the negative, it really doesn't matter, because whether it's negative 2 divided by 7 or 2 divided by negative 7, the actual numerical part of the answer would be the same, and having one negative, whether in the top or the bottom, yields the same result, a negative number. We'll conclude the notes with the last problem here, and as if we haven't tackled enough issues here in this video presentation, here is distributive property for us. So we've got half times 4 minus k equals 2/5. So you could, if you wanted to, go ahead and distribute right away here. You could do a half times 4 and a half times k equals 2/5, and then work from there. That is perfectly acceptable. That's a good option. You could, if you wanted to, instead of worrying about the distributive property, which just presents a whole other layer of challenge, just undo this right away. Now, if you're not seeing what I'm talking about, pretend this just said 1/2 times x for just a minute. If it just said 1/2 times x, you know exactly what to do because, well, that's a multiplication problem, so we're going to undo it by dividing. But you know what I'm about to say. We've never divided by a fraction. We've always multiplied by the reciprocal. So that, in this case, would be multiplying by 2/1. And that's exactly what you do. It doesn't matter that it doesn't say x. It doesn't matter that it instead says 4 minus k. Right? We're still going to do the same thing here, which is to multiply by the reciprocal 2/1. So let's go ahead and do that. When I multiply both sides by 2/1 here, on the left side, of course, those are going to cancel each other out and just leaves me 4 minus k. In the same way as if it just said x, those two things would still cancel each other out and just leave me x. On the right side, this one would just say 4/5. Well, this is pretty nice because this isn't really even a two-step equation now. It's just a one-step equation in essence, or at least it looks like one. We'll see why that's not true in just a second. But we know right away that if I'm keeping k on the left, 4's got to move. So let's go ahead and move the 4 at this point. So 4 right now is a positive. The opposite of a positive is a negative. The negative looks an awful lot like subtraction. So I'm going to subtract 4 from both sides. So I've got 4/5 minus a full 4, and that's going to be negative 3 1/5. Now, you can see what's wrong here, though, is that it doesn't say k. It says negative k now. Because realize if I cover up the 4 that I got rid of, it would indeed say negative k. I don't want negative k. I don't care what negative k equals. I want to know what positive value of k equals. Remember, whenever you have that, you just run across the line and change all the signs. Any additions would become subtractions, subtractions would become additions, positives would become negatives, and negatives would become positives. And you can do that earlier if you see it's about to happen when it's still in problem form. So I go through and change all my signs, and we end up with k equals 3 1/5.